Good evening, and welcome to Star Chat, the cosmic journey through the wonders of our universe. As we begin this episode, let's take a moment to appreciate the awe-inspiring beauty that surrounds our planet. Just recently, in the Pacific Northwest, a breathtaking sight lit up the early morning sky, a fireball, captured on video by Jason Jenkins as it streaked across the horizon. Imagine being on your way to work before dawn, and suddenly, a bright green streak beams across the sky, reminiscent of a lightning strike but far more celestial. This wasn't just any meteor. It was a fireball, a particularly bright one that can be seen from up to 80 miles above the Earth. The Oregon Museum of Science and Industry explains that such phenomena are often due to the presence of magnesium, which emits a bright blue-green light when heated and vaporized in our atmosphere. As we ponder the mysteries of meteors and fireballs, let's not forget the broader context, the billions of years of cosmic history that have led to these fleeting moments of beauty. The universe is full of such wonders, from the majestic swirl of galaxies to the intricate dance of celestial bodies in our own solar system. The sighting of this fireball is a poignant reminder of our place within the universe and the constant interaction between Earth and space. As NASA continues to explore the cosmos, missions like the ambitious Moon Base project underscore humanity's innate desire to understand and connect with the vastness beyond our planet. Tonight, on Star Chat, we'll delve into more fascinating stories from the world of space and astronomy. From meteors lighting up our skies to the latest developments in space exploration, we'll explore it all. We'll be right back with more fascinating space news on Star Chat. Welcome back to Star Chat. As we continue our journey through the wonders of the universe, we find ourselves pondering one of the most enduring questions in planetary science: what lies beneath the surface of our closest celestial neighbor, the Moon? For decades, scientists have been fascinated by the Moon's dark patches, known as Maria, which are concentrated on its near side. These vast, lava-filled plains have sparked a long-standing debate about the Moon's internal heat budget and the role of volcanism in shaping its surface. At the heart of this debate is the Procellarum Creep terrain, or PKT, a region on the Moon's near side that's rich in heat-producing elements. Researchers have proposed that these elements, collectively known as Creep, provided the necessary heat to melt the mantle beneath the PKT, creating the extensive volcanism we see today. But to confirm this theory, scientists needed to measure the temperature beneath the Moon's surface outside of the PKT. That's where the private mission Blue Ghost comes in. By landing outside the heat-rich terrain in an impact basin called Mare Crisium, the Blue Ghost team aimed to get a straight-up measurement of the Moon's internal temperature, unbiased by the PKT's unique composition. The results, presented at the Lunar and Planetary Science Conference, are nothing short of fascinating. According to planetary geophysicist Robert Grimm, the temperatures measured by Blue Ghost instruments were surprisingly close to those found beneath the Apollo landing sites. This finding challenges our current understanding of the Moon's internal heat budget and the role of volcanism in shaping its surface. It suggests that the concentration of heat-producing elements may not be the only factor at play, and that other processes, such as differences in crustal thickness, could have contributed to the formation of the Maria. As Grimm puts it, I think this reverses a quarter-century of thought about the PKT. While the debate is far from over, one thing is clear: we need more measurements to fully understand the Moon's internal dynamics. Fortunately, another private mission is planned for 2027, which will carry similar heat-measuring instruments to the Schrödinger crater on the Moon's far side. This will provide a crucial test of our current theories and help us better understand the Moon's mysterious past. Welcome back to Star Chat. As we gaze out into the vast expanse of the universe, it's easy to forget about the fascinating stories unfolding right here on our planet. Today, we're going to explore an innovative tale that combines two seemingly unrelated worlds: bourbon and battery technology. Imagine a world where the byproducts of your favorite whiskey could be transformed into powerful energy storage devices. Sounds like science fiction, doesn't it? But, thanks to a team of researchers at the University of Kentucky, this idea is becoming a reality. They discovered a way to convert the waste grains from bourbon production into supercapacitors that rival commercially available auctions. Behind every bottle of fine bourbon lies a trail of waste materials, including a goopy, mushy mixture of grains and corn known as stillage. In Kentucky, where 95% of the world's bourbon is produced, this stillage poses a significant problem. It's difficult to transport due to its watery consistency, and drying it is exorbitantly expensive. However, what if there were uses that justified the costs of turning stillage into different materials? This is exactly what the research team set out to accomplish. By subjecting the stillage to immense amounts of heat and pressure, they created a fine, black carbon powder that could be transformed into two types of materials: hard carbon and activated carbon. These materials have unique properties that make them ideal for energy storage applications. The hard carbon is great at absorbing lithium ions, while the activated carbon boasts an enormous internal surface area, perfect for housing large amounts of charge. The researchers experimented with creating double-layer capacitors featuring liquid electrolyte placed between coin-sized activated carbon electrodes. Laboratory tests showed their inventions held their own against commercially available electrodes, storing as much as 48 watt-hours per kilogram. But that's not all. Further experiments yielded a hybrid supercapacitor by combining activated and hard carbon electrodes, which outperformed existing options by around 25%. As we continue to push the boundaries of innovation, it's stories like these that remind us of the incredible potential for creativity and problem-solving that exists right here on Earth. Who knew that the waste from bourbon production could hold the key to revolutionizing energy storage? It just goes to show that even in the most unexpected places, science can lead to remarkable breakthroughs. As we close out today's Star Chat, remember that the universe is full of mysteries waiting to be unraveled, and sometimes the most extraordinary discoveries can be found in the unlikeliest of places. So, the next time you pour yourself a glass of bourbon, take a moment to appreciate the ingenious science that might just be lurking behind the scenes. That's all for today's Star Chat. Remember to like, share, and subscribe, and until next time, remember to keep looking up at the stars.